All right, we are starting Unit 3, and so Unit 3 is all about relations and functions. So we should have already gone over the notes and set our journal up. This first part, there are 3 entries before we do our first homework. So this homework actually has 3 videos attached to it. So the first one is about the coordinate plane. So we're going to start with the coordinate plane, and this should be a review for everybody, but it's always good to refresh our memories. So what is a coordinate plane? It is a plane divided into 4 regions. And we know a plane is flat, so flat means 2-dimensional. So it's divided into 4 regions, and it's used for graphing. Okay, so when you label everything, well, I want you to label the origin, the quadrants, the x-axis, and the y-axis. So think about your y-axis is like a yo-yo. It goes up and down. So here is our y-axis, and x is the xylophone. It goes this way. So a yo-yo's up and down, and then a xylophone is your x-axis. The origin is where x and y meet. Smack dab in the middle, that's called the origin. Your quadrants go in a counterclockwise position. So think of the letter C. When you write the letter C, you would start here and go that direction, counterclockwise. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So 1, 2, 3, and then 4. Quadrants are always written as Roman numerals. So I want you to write them in Roman numeral form because that's the pattern that we always use when we talk about quadrants. So go ahead and put that in your notes. Okay, an ordered pair. Now this is where it gets very, very specific. An ordered pair always fits the form x, y, and it is a plot on the graph. Plot or a point on the graph. And notice your ordered pair, it's always in alphabetical order, x, y. So if I want you to name the point, so point A is here. So imagine, I don't know, in elementary school you could have used like a turtle or something when the teacher was teaching you, but you always start here, and we're going to go on our x-axis to the -3 direction. So I'm going to go -3, +4. So to label point A, it's -3, +4. So watch how I do that. I start from the origin, and I go 1, 2, 3 places to the left, which is -3 on the number line. And then 1, 2, 3, 4 places up, which is +4 on the Y. So that's how I get -3, 4. And the quadrant is quadrant 2. So go ahead and fill those out for me real quick. I will do them up here, and you can either pause and check. That's fine. B is going to be +2, -3, located in quadrant 4. C is going to be 0, +2, and it's located on the x-axis. So it's not in a quadrant, it's just located on the, not x-axis, the y-axis. It is located on the y-axis. Point D is 1, 2, 3, 4, 5, 6, 7, +1, located in quadrant 1. E is -4, -6, located in the 3rd quadrant. And F is 1, 2, 3, 4, -5, 0, located on the x-axis. So that's just a refresher on how to name those points. Now, I want you to take a highlighter and highlight this right now. Discrete graph versus a continuous graph, okay? This is a big, big deal. We will be talking about this the rest of the year in algebra, so it is very important for you to know the difference between discrete and continuous. Discrete graph is a graph of distinct points. And I want you to think of scatter plots. When you think of a discrete graph, think of scatter plots because there are all those tiny individual markings where you can see. So over here is what a discrete graph looks like. Whenever we make our graph, we always label x-axis and y-axis, and a discrete graph is just points. They are distinct points. The reason we go through this is because there's one way to give a table for discrete graphs and then to give a table for continuous graphs. They're very, very different, so it's important to know these differences. So, discrete graph, individual points, think scatter plot. A continuous graph, on the other hand, is a line of connected, actually it's a graph, with connected lines and curves. So your example of that, I don't know if you can see, there we go, is going to look like this. Here's my x-axis, here's my y-axis, but a graph that looks something like this, okay? It can look like this. But it's got lines and curves in the graph. So it's very, very important you know. Discrete graph, individual points, just like this one up here. That's discrete. Continuous graph, connected points and curves. All right. Now, you have this on the back side. So let's go over this real quick. And a relation. So notice the top of here. This is all relations. So this is specific to relations as a whole. This is the big topic. This is a big overarching theme. So what is the definition of a relation? It's easy. It is a set of ordered pairs. And on the other side of this, we already said what an ordered pair was, right? We said it's this. And that's a relation. It is just a set of ordered pairs. The set of x values is called the domain, and the set of y values is called the range. And that is very important for you to know. Those are big definitions. So domain and range. And think about, have you heard the term, you're king of your domain? Everything that you look across, you're king of. So everything that you look across, your x values is domain. And y, if you're home on the range or riding up and down on a horse, so home on the range, is going to be y. So domain, all your x values. So when we were talking about a relation, you can write it 4 different ways. They all mean the same thing, but it can be written different ways. So we can write a relation as ordered pairs. We can write it as a table. We can write it as a mapping. And we can also write it as a graph form. So it's important that we go in between all of these, and it's very specific. So if you look here, when it's written as a set of ordered pairs, because there's more than one, that's why we have these brackets. And we've already talked about the use of brackets when it's more than one answer. So you have to start it with brackets because that's introducing what we're talking about. And notice my ordered pairs, there's 5 of them. Here's how I want your range written, and this is very, very important. If it's not written just like this, you will get points off. So make sure it is specific to what I'm writing. So when you write your domain, you are starting with your bracket because there's more than one values. Domain, least to greatest, numbers do not repeat. So I look at all of my x values. I have a -3, I have a -2, a 1, a 3, and a -3. So my least value is -3, comma. There's 2 of them. I don't put it down because numbers don't repeat. So -3 is taken, and then -2, and then 1, and then 3, and I close my brackets. Okay? Same thing with range, my y values. So I'm going to circle my y's, 1, 0, 2, -4, and 5. Open bracket, tells the reader there's more than one. Least to greatest, -4, 0, 1, 2, 5, close bracket. So, up here on number 1, numbers do not repeat. And we go from least to greatest. That is a specific form. Numbers, least to greatest, numbers don't repeat, domain and range. Okay? Now, how do we make a table? So to go to a table, I am literally picking up an ordered pair and I'm pasting it on there. So if I could literally pick this up and put it over here. I would. So like -3, -3, 1. Can I do that? I can pick it up and watch. I'm moving it over. Just like that. Except it has to fit a form. That was pretty cool. Are you impressed with my technical abilities? Okay, so -3 and 1. But what I don't want is I don't want it around parentheses. -3, 1. So imagine me literally picking them up and moving them over. -2, 0. 1, 2. 3, -4. -3, 5. So I'm picking them up and I'm moving them over. Now, it doesn't really matter for you to have them in least to greatest because the table's always going to change. So normally you see it, least to greatest, but if you have like a curve or a quadratic function, those numbers are going to depend. So I'm not specific on how you put it in a table, but that's what it looks like. Mapping. Here's another one on mapping. Very, very specific. You have 2 bubbles here. 2 bubbles. You must put D for domain and R for range. So really what this is you're taking your domain and range from over here and you're putting it in there. I want to make sure you can see this on. Hang on. We have scooted down. So okay, sorry. So domain and range, you put a D and an R. So remember over here we wrote the domain and we wrote it from least to greatest, numbers don't repeat. And we put the range, we said -4, 0, 1, 2, and 5. So basically what I'm doing is I'm picking it up and I'm putting the domain here. Least to greatest, numbers don't repeat. Range, least to greatest, numbers don't repeat. That's how I fill it in, domain and range. Now, here's the thing. You are going to attach these points with a line, and it has to have an arrow on the end. So, -3 belongs to 1. So I'm going to draw a -3 to 1. Notice the arrow goes to -3 to 1. You must have an arrow on that or points off. It's not just a line segment. It is a ray. 1 point here. -2 goes to 0 with an arrow. 1 goes to 2 with an arrow. 3 goes to -4 with an arrow. And then -3 goes to 5 with an arrow. So the reader can still look and see that -3 and 1 is an ordered pair, -3 and 5 is an ordered pair, -2 and 0, 1 and 2, 3 and -4, okay? The last way we do it is we graph those points. So we already know how to graph based on the previous page. So over here, it would be -3, 1 is a point, -2, 0 is a point, 1, 2 is a point, 3, -4 is a point, and -3, 5 is a point. So that's how I have filled in ordered pair, table, mapping, and graph. What I want you to do is I want you to look at example number, let me see, this last example and see if you can fill it in. Notice we're working backwards. It's giving you a graph, but now we need to do the mapping, the table, and the ordered pairs. So I am going to let you pause and then come back and I will give you those answers, okay? So here we are. There's a set of ordered pairs. Remember, it's specific. So I'm going to do 1, 2, 3, 4. -5, -4. -5, -4. That's one ordered pair. -2, 3. -2, 3 is an ordered pair. Or 0, -3 is an ordered pair. 2, -5 is an ordered pair. And 4, 2. 1, 2, 3. Yeah, 4, 2 is an ordered pair. So I filled in my ordered pairs. Notice the bracket. Now for domain, least to greatest, numbers don't repeat. Domain is my x values. So -5, -2, 0, 2, and 4. Close bracket. My range, I've got a -5, a -4, -3, a 2, and a 3. So -5, -4, -3, 2, and 3. Numbers don't repeat. My table, remember, is just taking my order pairs and plugging them in. So -5, -4, -2, 3, 0, -3, 2, -5, 4, 2. Now, my mapping, domain, range. So it's simply, I'm picking this domain up, putting it in. -5, -2, 0, 2, 4, numbers don't repeat. -5, -4, -3, 2, 3, numbers don't repeat. And I attach these numbers together with a ray. So -5 goes to -4, -2 goes to 3, 0 goes to -3, 2 goes to -5, and 4 goes to 2. And then my graph was given to me. If you have any questions, let me know. That was only one video. Sorry, guys, I know they're long.